Hello, so today I'm going to take you through my PROG7312 POE, the final part. For the final part, the data structures I used was a binary search tree and a graph. As you can see here in my models folder, these are my custom data structures I made from scratch. As you can see, binary search tree and graph. So let's start with the binary search tree. For binary search tree, we have a node class that inherits from the icomparable class and has properties such as value, left and right, and then a constructor. And then we have the binary search tree class, which also inherits the icomparable and has its own properties such as root, count, and then a constructor. And then the methods we have for this custom binary search tree is an insert. So we can insert values into the binary search tree. And then in this insert method, we use recursion, so it calls itself the method itself again. We have a search method to search for values, and again we use recursion again, where we call the search. As you can see, we call the search method in itself. Then we have a contains method that just checks if a value exists. We use an in-order traversal to sort the list, and then again we use recursion call itself. And then we have a pre-order traversal, also uses recursion, and we have a post-order traversal again that also uses recursion. And then last we have a get all method that just calls the in-order traversal method. So the one that's actually being used is in-order traversal, which will just get all the values as a list and will be sorted. And then we just have a clear method, so we can clear the binary search tree. Our next data structure we have is a graph. So we created a node class with the properties of ID, name, and then a list of edges. And then we have a constructor, and then here's the edge class that we created with properties such as target and weight, and then its own constructor. Then here's my own graph I made. I call it EB graph. I have a list of nodes of the node class, and then a constructor. We initialize it, and then we have an add node method. So we just add a node to the graph data structure. And then same, we have a add edge method where we add edges to the graph. And then we have a get node method. So we basically find we get nodes based on ID. Our graph uses a breadth first search for finding dependencies between the service requests. And then we have a get all dependencies method. So it will get all dependencies for a specific node. And then we have a get dependence method, which gets all nodes that depend on a specific node. So like based on the ID, it will get all the others that depend on this ID. And then in our main logic, our controller class. So yeah, we have a service request class, just good practice, I guess. Our getters and setters and various properties such as ID, title, category, description, date, status, priority, progress, and then a list of type string all depends on, and location. And then we have our constructor. Then we have this compare to method, so it will just basically compare service requests by ID, and we'll use the binary search tree for sorting. And then here's our controller. As you can see, I initialize my own binary search tree. Same thing for my graph. I initialize my own graph, as you can see, EB graph. Then I just have a simple counter, request counter used for generating IDs. And then we have a is initialize set it to false. So basically, this is to do with my sample dummy data to make sure it's only loaded once. And then, as you can see, we just check if it's not initialized, and then we call it and set it to true. Then here's the HTTP get. So when we arrive on the page, it takes all these parameters, search ID, photo status, and photo category, but we only using search ID. So our getter, we have a var variable that gets all requests from the binary search tree, which is sorted based on ID, and then we just search for specific IDs that the user enters, basically, and it will be highlighted. And then we also get dependencies using our graph by breadth first search. As you can see, I call the methods get dependencies from my classes. And then the view back is just to pass it to the view, so it appears on the front end, and then we just have our catch if any errors appears. So our get request by ID method basically searches for request by ID using our binary search tree in the time complexity of O log n, and then I call my binary search tree method to find the request by ID. I also have a get all requests, which basically gets all the service requests and sorted by ID again, but uses in-order traversal. As you can see, I call my in-order traversal method, and then I get a request by priority. Another method I have is a get dependency, so this will use my graphs breadth first search, and then I call my graph methods to get dependencies, so like my get all dependency method. Here's a get dependence method, just gets all requests that depends on the current request. And then I have a get statistics method, which is just basic stats about the service requests. And then last I have a add a request. So this is how I was adding dummy data. So this is my add request method, which adds dummy data to my binary search tree and graph. And there's update request status as well for the dummy data in my initialized sample data. This is all my dummy data that we were allowed to add. Okay, so I'll now run the application. As you can see, here's the homepage. Service request status is now applicable. And as you can see, this is now, it's almost grayed out. It's available. So I'll click service request status. As you can see, here's all the service requests, ID, title, see if it has a dependencies. Like this one has one dependency, category, the priority, the date, the status. And then here's the statistics part and showcase of high priority part. And yeah, that's all the data. I'll show you the search. So we can search by, so I'll do the first one. So we search for SR0001. And as you can see, this is the progress of that service request. So now, like, let's say I choose 15, which has a dependency. So I'll just do 15. As you can see, this has a dependency. It shows you which one it's dependent on before it can be completed. And then I'll show you also if we just type random things, it works. As you can see, it handles that gracefully. So yeah, so the displaying of that is using my binary search tree, and then for the dependencies, it's using the graph data structure. And then I'll just show you, I guess my thing works on different screen sizes again. So as you can see, it looks good for all screen sizes. Thank you. So.